Hey everybody, welcome back. Gary Simmons here for the Game Institute with lesson 116 in the Dead Earth game development series. Okay then, so not really a lesson this time, but more of an orientation video, because we have just deployed to the Game Institute website the hospital demo level of the Dead Earth game, and this project has evolved significantly since the previous project that I've deployed. So what this is going to be about really is just showing you how the project is laid out, how you actually run the project in the editor, because in previous projects we were just working with a single scene, the hospital scene, but now we've put all of the support scenes into place. So we've got the bootstrapper scene, the main menu and options screen, closing credit sequences. We've got an intro video sequence that plays if you're playing the game for the first time. And we've also had to make sure that the hospital scene itself, because its combined assets span the 4.6 gigabyte boundary, which Unity doesn't like, we've had to kind of carve up the assets across two scenes so that they load correctly in the built game. Okay, so first of all, in order to get this project, you need to go to the Game Institute website. So let me call up my browser a little bit. And as you can see, I'm in the catalog. And you need to go to the projects channel, click on Dead Earth. And you'll see what we've done actually is while I've been working on this project, I've also gone back and updated all of the projects so that we have versions of the projects and the source code in Unity 2018 LTS, which is my recommended version to use for Dead Earth. But at the time of recording this video, 2021 was the latest version. So I also deployed a version of the project and all of the previous projects in 2021 as well. So as you can see, when you go to the projects channel now for Dead Earth, you get two folder options so that you can access all of the projects in either 2018 LTS or 2021.1. Now, I have also recorded the first two videos for this lesson where I describe why I've chosen 2018 to stick with. But basically, since 2018, especially with respect to using the built-in pipeline in Unity, performance has been dropping off a little bit, and I have noticed a significant frame rate decrease between 2018 and 2021. And it's not just me, lots of people complaining about it on the Unity forum. Unity technologists say this isn't the case, but I've tested it myself, and I am definitely seeing like places where I used to get between 60 to 80 frames per second on my computer in Dead Earth, I would now get 40 frames per second, 40 to 50. And then in other places where I used to get 300 frames per second, it kind of seems to almost max out at around about 120, 130. So a definite significant frame rate drop in 2021. And I'm talking about the built game here versus 2018. So if you want to install 2018 LTS, you can do that through the Unity Hub. I show how to do this in lesson 2. I've re-recorded that lesson as well. Go to 2018 folder in the projects, and there you go, lesson 116. And just like all of our bigger projects, this is a 7-zip project, so you need to have 7-zip installed, download all of these modules individually, and then when they're on your hard drive, just extract the first one using 7-zip, and it will consolidate all of the files together and reconstitute the project on your hard drive. Here we are now in the project of Dead Earth. Like I said, this is the 2018.4 LTS version of Unity. At the moment, I am in the bootstrapper scene. So what is the bootstrapper scene? Well, the problem with things like our application manager and our audio manager and the new input manager, which we'll talk about in a future lesson, is these are what we call don't destroy on load objects. In other words, we only ever want them to be created once, and then they need to be alive across all scene loads until we exit the application. So in the case of the application manager, when the bootstrapper scene runs, which only runs once when we first start the game, the application manager, the audio manager, and the input manager are created, and then they're never destroyed. So when we load into the main menu scene or the main hospital scene, these will remain resident in memory. And these have had to be moved into the bootstrapper scene now, because if we left them in the hospital scene, then every time we played the hospital scene, died, and then decided to play the hospital scene again, each time we reloaded it, a new version of the application manager, audio manager, and input manager would be created. So we'd end up, every time we load in the hospital scene, we'd create these 3 objects all over again, and then all hell would break loose, because we'd have like, after 5 tries on the hospital scene, we'd have like 5 application managers in memory. So what I pretty much do with all of my projects when they get to this stage in development where I start putting on menu screens and start making it look like a proper game is I have a bootstrapper scene, which if I go to the file menu and bring up the build settings, you'll see the bootstrapper scene is the very first scene in the build list. This is the scene that will first run when we click on that icon to launch the game on our desktop. And all this scene actually does, really, is it just automatically, by way of the fact that they're in the scene, it creates the application manager, the audio manager, and the input manager. All of these are set as don't destroy, unload objects. But it also has a script on the main camera called the bootstrapper script. You can see if I open that up, really simple script, it just waits for 3 seconds before invoking the load menu function, which basically just loads in the main menu scene. So really this bootstrapper scene just exists to show us this nice little image on the screen for 3 seconds, create the application manager, the audio manager, and the input manager, and then load into the main menu scene. Now, the reason why it's important that I say this is because the game will not run correctly in the editor unless you press play from within the bootstrapper scene. Because if I just load up the hospital scene, so let me go into my scenes folder, my Dead Earth folder, and load up the hospital scene. So here we are now in the hospital scene, and if you look in the hierarchy, you'll remember that it was in here that we used to have the audio manager and the application manager. They are no longer present because they're going to be carried over from the bootstrapper scene. So if I press play now, nothing is going to work, and we'll probably get a whole host of errors showing up in the console because the application manager and the audio manager are missing. So you can see, first of all, I'm moving my mouse, I've got no input because the input manager is not present, there's no sound, I can't do anything, it's completely broken. And if I look in the console window, I'm pretty sure there's going to be a whole load of errors there, and you can see there it is, and it's all to do with missing references to the application manager and the audio manager and the input manager. So in order to run the game, you obviously have to load in the bootstrapper scene first, then press play, and everything should work then as normal. So there should be a 3-second delay. There you go, we're at the main menu scene. From here I can launch the options. I can bind new inputs to the inputs that are set up. That's one of the new features in this project, is I've written a customizable input manager, and that was pretty necessary. I wasn't actually going to do that, but the problem is that in 2021, or it may have been in an earlier version because I didn't really do much in 2019 or 2020, they actually got rid of the configuration dialog where users used to be able to configure their input. So because we're using the older input manager and not Unity's new, in my opinion, overcomplicated input manager, I just decided the best thing to do with that configuration dialog gone is just simply write my own input manager so that I can control the bindings myself. So you can see if I go into new game, this will now load in the intro sequence. This is a very simple scene really that just plays a video. It's just a video player scene. And you can see if you've played the game before, it recognizes that and it gives you the option to skip the start sequence. Then we go into the loading scene. Where we should get a progress bar while it's loading. Now the progress bar works a lot better in the final build. In the editor, it's kind of like, it looks like it's not loading at all, and then it's almost shoots up to sort of 100% instantly. But that's just because things don't quite, work the same in the editor. It's very much a approximation of what you're going to get in the final build. Although the game runs okay in the editor, it is significantly faster in the build, mainly due to the fact that we use quite a lot of physics and colliders and triggers, and in the editor they are not hardware accelerated, and when you build the game they are, and that makes quite a big difference. So if you are a bit worried about performance in the editor when you've got lots of zombies going on, it's probably more to do with that than anything else, and you'll probably find it's significantly faster in the final build. So there you go. So we're now, everything's working fine. We've got a mission manager, we can pick up objects, so we can swing, we've got all of our sound, and everything works fine. And we can also quit back to the main menu as well. That's a new thing that I added. And we've also, if we quit the game, we've got a closing credit sequence. There's a full walkthrough on the Game Institute website, so if you can't be bothered to play through the game and see all of the bits, you can watch me playing through the game, and that can be found in the resources area of the Dead Earth course. this raises some concerns when we're working on, let's say, a scene like the hospital scene, and we're tweaking various assets and that in the scene. It's a real pain if every time we want to press play to test it, we have to, first of all, via the editor, load in the Bootstrapper scene, press play and go through the whole sequence of the main menu and things like that. But you don't have to do that. What you can do if you want to do this just temporarily is you can load in the hospital scene and you can just drag in the application manager, the audio manager and input manager prefabs into the hospital scene, right? So let me go to my prefabs folder and let me go into the scene view. It doesn't really matter where we stick them in the scene view. So where's my application manager? Just drag that in there. And there should be my audio manager. I'll drag that in there. And then my input manager. There it is. I'll drag that in there. And now I can press play from the hospital scene and everything should just work just as it would in the real game. Yeah, there you go. And everything's working as it should. Yep, all working fine. Oh, don't worry about these warnings. That's just the fact that one of the fonts I'm using, Unity is telling me that certain characters aren't available, but they're not characters I use anyway. Yeah, so one of the things you have to make sure is that once you've got your kind of hospital scene how you want it, and then you build the final game, it's really important that you remember to remove the input manager, the audio manager, and the application manager from the hospital scene, right? Because when the game runs, it's going to create these three managers automatically in the Bootstrapper scene, and then when we load into the hospital scene, it's going to create copies of them. And in fact, every time we reload the hospital scene, it's going to create another copy of these because these are don't destroy and load objects. So this is fine by dragging these prefab managers into the hospital scene for while you're working within a hospital scene. But once you're done, it's very important that you delete these, okay? Or otherwise all hell will break loose. Okay, so the next thing I want to talk about, if I go back to the scenes folder, is I mentioned that there is a scene in here called Hospital Asset Cache. Nowhere in our code do we ever load this scene. But the way that Unity works when you build your game is it will package all of the assets into compressed cab files that are based on the first scene that they are used in, right? So you could imagine, scene 1 would have a resource file called something like 001, and then all of the assets used in that scene would be included in that file. So in our game, before I did this split, pretty much all of our assets were used in the hospital scene. And our assets actually came to much larger than 4.6 gigabyte, which meant that when we built the game, actually, let me use exact numbers here. So the hospital scene here, if we imagine the hospital asset cache scene wasn't there, it would be 1, 2, 3, 4, right? It would be the fourth scene. So what we would have is a resource file called 004 when the game was built that actually was something like, 6.5 gigabyte in size. Now the problem is that Unity just doesn't work if any of its resource files in the final build are larger than 4.6 gigabyte. It's been like this since forever and they don't seem to be in any hurry to update this. But it doesn't really matter because we can easily assign some of the assets to other kind of fake scenes. And the whole point of doing this is just so they get put in a different resource file when the game is built. Like I said, we don't have to even worry about loading this scene or anything. All we have to do is just drag a load of assets into that scene, make sure, in our case, that the hospital asset scene appears above the main hospital scene in the build list. And then any assets that we assign to that scene, even if they are used by the hospital scene, will be assigned to this scene's resource file instead of the hospital resource file, therefore bringing down the size of the hospital file and splitting that 6.5 gigabyte into a hospital scene resource file, which is 2 gigabyte and or 3 gigabyte, and a hospital asset cache, which is 3 or 3.5 gigabyte. And you can see if I load up the hospital asset cache scene, right, there's nothing in the scene at all because this scene never gets loaded or displayed to the user. So all I have in this is a single game object, right, that has a script on it called scene asset cache. And let me just, before I show you what's in the asset list, let me just show you how simple this script is. As you can see, it has as a public variable a list of Unity Engine objects. Now, pretty much all of the assets in Unity are derived from Unity Engine.object. So that just basically gives us a list in the inspector where we can pretty much drag in anything that we like. Textures, sounds, scriptable objects, just anything that's derived from Unity Engine.object. And you can see, because I've now assigned all of these assets, and there was no real kind of method here, I just dragged in loads of materials that are used by our hospital. And of course, because because the materials also use textures, it means all of their textures also get bound into this scene's resource file as well. We never load in the hospital asset cache. It literally just exists in the build list so that when Unity is building our game, it recognizes that these assets should be bound to this scene's accompanying resource file and not the main hospital scenes. Okay, I think we've got it. So I've now shown you how to run the game in the editor. I've shown you also how to temporarily add those manager prefabs to the hospital scene. So if you're working in the hospital scene, you don't always have to go back to the bootstrapper scene to press play each time. Going back to the hospital scene one more time before I finish up, something I just want to point out is that obviously in this hospital scene, you can't see by default any of the detail objects in any of the rooms because we've got PVS enabled. But in the editor, if you just want to see all of the stuff that's active at startup, just go to your search menu in the hierarchy, type PVS, and when the PVS object comes up, just say PVS enabled and unclick that. And then you'll notice then that although it will run a bit slowly, pretty much everything pops into view and all of our furniture can be seen, and it gets a little bit kind of sluggish in the editor because of that, but it does allow you to fly through and see all of the new sections of the hospital that we have added. Okay, so let me type PVS again. Obviously very important that you undo that and re-enable PVS before you build your game, or performance will absolutely suck. Now the other thing, I'll just point this out just because obviously I don't know if things are going to change slightly when it's loaded into your version of Unity. We now have a mini-map system in the game, and if you've played the game or followed my walkthrough, you'll know how this works. It's a pretty simple system, but it relies on me placing big pictures of the maps in the scene, sort of above the areas of the hospital that they represent. These maps are on a layer called Blueprints. Here you go. So what I'm pulling down here is the layers drop down for the actual editor. So this controls what gets shown in the scene view. And you can see that by default, I have turned off the blueprints layer. And that's because if I don't, this is what you will see in the scene view. You can imagine that our blueprint camera is kind of following the player around, only rendering this object here. It's not rendering the scene underneath it. I mean, we're going to put a detailed video together showing how the blueprint system works. Above each level of the hospital, I've captured what the hospital looks like from that location. And then I've taken that screen grab of the scene view into Photoshop, drawn a much nicer map to represent it, and then brought that map back in, mapped it to, I've mapped it to a cube. Really, it should just be a plane, but it doesn't really matter. And then we have a camera that is above the player. That camera literally just renders things on the blueprint layer. So it will just render this map based on where the player is within that map. And we render it to a render texture so that we can then use that render texture in a material that is used either on the UI or in our inventory scene. In this case, there's actually 3 different map positions because we have 3 copies, if you like, of the hospital, 3 sections of the hospital. So as we move from one section to the next, the blueprint camera snaps from one location to the next as well. So we always make sure we're rendering the correct blueprint. And in fact, it's slightly more complicated than that. The blueprint images are actually set at runtime based on what floor of the hospital we are on as well. So I think, if I remember rightly, in this middle section of hospital, there's actually 3 blueprints because there's 3 floors. There's only 2 floors here and 2 floors over here in this rightmost hospital. What we do is we have triggers so that when we enter certain floors and certain hospitals, we can tell the blueprint system, hey, we are on level 2 of hospital 3. And then it can jump to hospital 3, and then it can select the correct blueprint texture to display on this cube here. And then, of course, the camera will then render it. Okay, but the reason I mention that is because if you load in the scene and these things are active in your scene window, then it can become a little bit of a pain to work with. So just from the layers menu, just disable blueprints. And like I said, we'll talk about the blueprint system in a lot of detail in a future video. There's so many things, obviously, that we're going to talk about. The AI has been completely refactored. So whereas we used to have an AI state machine and then an AI zombie state machine, we've carved that up now into a much finer object-oriented hierarchy so that we've got like the base state machine and AI state machine. Then we have a humanoid rig state machine and a non-humanoid rig state machine. And it's in those state machine classes that we have all of the IK targeting stuff for the humanoid rig. But we also have variants of it so that if we're not using a humanoid rig, if we were, let's say, say, bringing in a zombie dog, then we know that none of that IK retargeting is supported by Unity. So we create a separate branch that has, it's kind of like the zombie state machine, but has all of the IK stuff gone. And that means that the actual zombie state machine and other things that we derive from the humanoid state machine, like the Bub state machine and the Mayweather state machine, they're normally really simple classes that just override one or two functions to get some bespoke behavior. Now, although the AI code has been split up into these different files, you can see now if I go into the scripts folder and into the AI folder, we've got like the base rig here with all of the states and stuff, and then we've got the humanoid rig here, which has all of the IK stuff. So that's kind of looks a little bit different to how it used to look. The code is mostly the same, but we have added to the code. So one of the things that we found when we were working on this game is that one of the biggest performance bottlenecks by a long shot when we put zombies into the scene was having all of those zombies animate even when they weren't visible. So what we added was a system whereas when a zombie isn't visible, we no longer animate it. Now that caused a bit of a problem for us because we use the root motion in the animation to actually calculate the movement of our zombies, how fast they run and walk. So the minute we stopped animating them, they stopped moving as well. So we had to put this little subsystem in place that said if its animations are currently being culled, then move them by this amount that we basically read in from the root motion of the animation that it would be using. So that sped up things quite a bit. But what was really expensive is if we just turned on obstacle avoidance on their nav mesh agents to stop them walking through each other and stop them walking through nav obstacles. One of the things that we did is we put a system in place that made sure that we only turn on obstacle avoidance if we need to. But we're going to dedicate a whole lesson to the changes in the AI and how we've added a congestion system. And in fact, we've even added a whole new method for the way in which zombies track to the position of the player. Now, hopefully you'll remember in previous lessons when we wrote our AI script that what used to happen is if the player registered as a threat for a zombie, then we would get the player's position and we would call the sample position function of Unity to give us the nearest position on the nav mesh, because it's possible, in our level at least, that the player may have wandered off the nav mesh. Now, I've tried all sorts of functions in Unity, but the problem is with it is it's just fundamentally broken with respect to how we need it to work. And that is, let's say, for example, let me give you an example of this. Let me say the zombie is chasing me, right? And there's a bench here where my mouse is, right? And the player jumps up on the bench. Now, it just so happens that the nav mesh doesn't encompass the bench. So the player, when he jumps up on the bench, is actually off of the nav mesh. Now, the real problem with this is when I send the player's position, which remember isn't on the nav mesh, to Unity's sample position function, which remember is supposed to give me the closest position to the player on the nav mesh. What it does is it first says, hey, this position they've given me isn't on the nav mesh, so I will find the closest position by casting a ray down from above. And what happens is Unity will then give you a position back that is on the floor above you. So I would jump up on a bench, all of my zombies would be running towards me, and the minute I jumped up on the bench, they would all break off pursuit, run up the stairs, and they'd try and attack me up here. And we tried all sorts of things to get rid of it, but what we ended up doing in the end, believe it or not, if you look in the hierarchy, and once again, we will discuss this in the AI upgrade lesson, but just to give you a place to look, there's actually an object in here now called target follower. Target follower is actually a nav mesh agent with a script on it. Now, this nav mesh agent never paths, it never does kind of anything, but what it does do is it has a script on it that is constantly trying to move it to the position of the player. Now, the reason why we did this is because when we were trying all of the things to try and fix this problem with the sample position function, what we realized is that if you try and pick up one of our zombies in play mode and try and drag it off of the nav mesh, Unity is very resistant to that. We literally clamp it to the edge of the nav mesh, and that was exactly the behavior that we wanted. In other words, if the player went off of the nav mesh, we wanted the zombie to target the location that was on the edge of the nav mesh closest to the player. And the way that we found that we could do this was have this intermediary object, if you like, this nav mesh agent that we just constantly try to move to the player's position so that when the player actually leaves the nav mesh and we try and push this nav mesh agent to the player's position, it gets restricted and bound to the edge of the nav mesh. And it's actually this thing now that is the player position from the zombie's perspective. So the zombie is always heading towards this and trying to track towards this It's a little bit complicated, but like I said, when we get to the lesson on that, I will fully describe it. And if you want to see how it works, you can see here is the target follower script that basically makes sure that this thing is always trying as much as possible to follow the position of the player. So let me just open up the zombie and I'll show you what I mean. So basically what the target follower does is it writes its position to basically a shared vector 3 called position sampler. And if you look at my AI zombie state machine here, you can see that our zombies are now given a reference to this position sampler. Okay, so this position sampler, like I said, it's kind of a fancy shared vector 3. It will always be getting written to by the target follower, the current position of the target follower. So either the player's position or the closest position that the target follower can get to the player. And whenever the zombie knows it's following a player threat, it just reads in the player position from this position sampler. And you can see if I select the target follower again, the target follower script also has a reference to that position sampler, and it is literally just writing its position to this position sampler each frame. Okay, cool. So the other thing that has changed significantly, like I said, I will cover all this in the AI lesson, is that we always used to do threat analysis sort of individually on a zombie basis. So each zombie would have this great big sensor sphere collider around it, and it would just react to any threat that came into its sensor trigger. Now, the sensor trigger, folks, is now completely gone. If I select this zombie and I open up the zombie, you can see now that there's a target trigger, but the sensor trigger is now gone. The sensor game object is still there. This is where we wish to kind of measure threats from. And this is game object here is the object that used to have that big sphere collider on it that used to register all threats coming into the sphere. But that is no longer the case. And once again, the reason why I did this is because when I started adding the idea of friendly zombies, our zombie bub, that meant that in the past, where zombies were really only testing for the player or hostile threats coming into its sensor, once we allowed zombies to also be possible hostile threats to other zombies, we were just getting absolutely clobbered by all the trigger messages that all of the zombies were generating off each other. It was pretty crippling in the editor. Now, because we have hardware accelerated physics in the built game, it was not nearly as bad in the build, but it was still an issue, and you could just see that we were just getting so many, like literally thousands of calls to the on trigger functions, and that was not good at all. So what we decided to do instead is we decided to create an AI manager, which I should be able to find in this hierarchy soon. Oh, there it is. It's called Game Scene Manager and AI Manager. They're on the same game object. So there's the game scene manager that we've always had, although now it has support for cut scenes, but we'll talk about that in another lesson. And you can see we now have this AI manager, and the AI manager basically takes care of only processing so many zombie threats per frame. It sort of does it in a round robin fashion, okay? So it allows us to say, in this particular case, that I want to do one test. Now, if we wanted to slow that down, we could put 2 here, and then it would only test for zombie threats every other fixed update. But I've said I want every fixed update it to do a test, and I wish it to test the threats of 10 zombies. So we've got 100 and something zombies in level, so it just basically means we're never getting bogged down. And because we've removed that sensor trigger from all of our zombies, we're no longer getting clobbered by the thousands. In fact, to be honest, if I remember rightly, it was over 10,000 on-trigger enter and on-trigger exit calls, because we're kind of doing the collision tests manually now, doing kind of overlap sphere and overlap capture tests inside the AI manager script. So it's much more performant. But like I said, open up, have a look, but there will be a lesson where we discuss the code to this in detail. The main point of this was just to show you, how to get the game running and where to start looking for things of interest before we record the videos that's going to explain all this stuff in more details. So enjoy the project, guys. There's plenty of stuff to look around. Things have changed quite significantly since the last deployment. I will see you in the next video. Bye-bye now.